Rosyth 2024 Prelim Paper 2. Question 1. Figure below shows a triangle EFG has a perimeter of 84 cm. Find the value of P. Okay, so first, the total, let's add them up first. Since we want perimeter, 8P minus 9 plus 3P plus 21 plus 39. Let's simplify this. Make sure the sign goes with the number behind. So you can do this to make sure you don't make any errors. If we start with 8P, let's bring all the like terms, all those with P to the front. So that's a 3P. And everything else to the back. 8P plus 3P is 11P. Now be careful about the back. Be careful about this one here. Okay, let's do this first. It's not 9 plus 21, but like minus 9 plus 21. So you are taking away, imagine losing 9 and then gaining another 21. That would mean overall you gain 12. Okay, then you have a plus 39. So this is 11P plus 51. This 11P plus 51 is the perimeter, which is 84. So to find 11P, it's 84 minus 51, which is 33. So P, 1P or P would be 33 divided by 11, which is 3. So answer 3. Question 2, Madam Rosna needs some pieces of ribbons, each of length 36 cm to tie gift bags for a party. She bought 3 rolls of ribbon. Each roll is 15 meters long. What is the greatest number of such ribbons that Madam Rosna can cut from the 3 rolls of ribbon? Okay, so firstly, if we look at each roll, right, we need to determine how many pieces can you get from each roll. So each piece is 36 cm long. Each roll is 15 meters. So 15 meters, let's convert to cm. Every meter is 100 cm. So add 2 zeros behind. So with this 1500 cm, how many pieces can you get? So every piece is 36 cm. So we take 1500 divide by 36. That will give us 41, remainder 24. So there are 41 pieces from every roll. She bought 3 rolls. So 3 rolls would be 3 times 41. 123 ribbons. Question 3. Chairs are arranged in straight rows in a hall. There are 42 chairs in each row. Each chair has a length of 0.5 meters. Every row is 1.5 meters apart from the next row. There are 1470 chairs altogether. So what's the distance between the first row and the last row? So this is your first row and this is your last row. It's indicated by this line here. Okay, you're supposed to find this, the value of this. Okay, so firstly, 1,470 chairs altogether. If every row you have 42 chairs, how many rows will there be? So number of rows. So the number of rows will tell us like how far apart they would be. Okay, so this is important. You need to find this. 1470 divide by 42 because every row has 42 chairs. Means that there are 35 rows. Okay, so this is like row 1. And this is row 35. So every the space, the interval between 2 rows will be 1.5 meters. If there are 35 rows, right? How many intervals would there be? So the number of intervals would be 1 less. Okay, so minus 1. Now 35 rows would be 35 times 0.5 because every row is 0.5 meters wide. So that's 17.5. And then for the intervals, if there are 34 intervals, every interval is 1.5 meter as shown in the diagram. Then this will give us 51 meters. So add them up and you get the total distance between the first and the last row. Okay, add them up, you get 68.5 meters. All right. Question 4 in the figure below, ADE here, equilateral, and then ABCD is a square. So you want to mark out all the equal sides. Equilateral means all the sides are the same. Squares means that the sides are the same as well. So you have like many equal sides. Okay, find AFC. AFC is over here. Okay, let's find EDC first. This is right angle. And this is 60. This is 60. This is 60. Angle EDC would be 90 plus 60. So if you can see, there's actually an isosceles triangle EDC here. Okay, because these two sides are the same. So with that, I want to find angle FED, this FED. So I'll take 180 minus 150 and then divide by 2 because it's isosceles. The two angles are the same. Okay, so angle DEC or DEF 180 minus 150 divide by 2, which is 15. So this over here is 15 degrees. Now let's find EFD, which is 180 minus 60 minus 15. Okay, so I minus off this, minus off this. Sum of angles in a triangle. So 105. EFD is 105, so angle AFC, because it's vertically opposite, is also 105 degrees. Okay, so answer 105 degrees. Question 5. Dylan and Greg set off from the school at the same time and jogged towards the stadium using the same route. They jogged at a constant speed throughout the whole journey. When Greg covered 1/4 of the distance, Dylan was 300 meters behind him. Dylan reached the stadium at 9 a.m., jogging at a speed of 100 meters per minute. What time did Greg reach the stadium? Okay, so you have two people here from school to stadium. So they started at the same time when Greg covered 1/4. So when Greg is here, Dylan would be 300 meters behind. Sorry, 1/4, not 2/4. So maybe like that, 300 meters here. Okay, so Dylan is the slower one. When he reached the stadium at 9 a.m., he reached at 9 a.m. His speed is 100 meter per minute. So what time did Greg reach the stadium? Greg would have reached before. So for every 1/4 of the journey, Dylan would be 300 meters behind. So if this is 1/4 of the journey for Greg. So if you have 4/4 of the journey, the whole journey, which means that G completes, Dylan would be 1,200 meters behind. Okay, so here times 4. So if Dylan, okay, when Greg finishes the journey, Dylan would be 1,200 meters behind. So for Dylan to catch up with Greg, right? He's at a speed of, not catch up, but for Dylan to reach the end point, if he's traveling at a speed of 100 meter per minute, how much longer would he take for this 1,200? So the extra time needed by Dylan would be 1,200 divided by 100. Okay, so this is 12 minutes. So when Greg has finished the distance, the journey, right, Dylan would take 12 minutes more. And by the time he takes that 12 minutes extra, it would be 9 a.m. already. So what time did Greg reach? So from 9 a.m., we go backwards by 12 minutes. So this is 8:48 a.m. Okay, so the 12 minutes is the extra time taken by Dylan, and then by then it will be 9 a.m. So that's why we need to work backwards, because Greg already reached the stadium before 9 a.m. All right, question 6. Mr. Fan had a total of 1,370 oranges and pears at first. He sold 4/7 of the oranges and 265 pears. The number of oranges left was half the number of pears left. How many more pears and oranges were there at first? So starting with total, 1,370. He sold 4/7 of the oranges. So the oranges minus 4/7. So 7 take away 4, left 3. Then for pears, sold 265. In the end, we have the ratio O to P. Oranges, 1/2 of the pears. Then we find common base between the two ratios. I have ratio here, ratio here. Number of oranges in the end is the same. So if this is a 3, then this oranges here must be 3 also. So what we do now is going from left to right, starting with 1,370. You minus 4 units minus this equals to this. Okay, total at first minus 4 units minus 265 will give us 9 units. Okay, combine 1,370 and minus 265. Key in the calculator, you should get 1,105. Then keep the minus 4u equals 9u. So what is 1,105? This has to be 13 units. Right? 13 minus 4 is 9. So 1 unit is 85. What are we finding? How many more pears and oranges at first? Difference between pears and oranges. Since I have 1 unit, I can find the number of oranges at first, which is 7 units. So number of oranges at first is 595 after you have found 7 units. Now, you want to find pairs. The fastest way is to take 1370, the total at first, minus away the oranges at first. Seven, seven, five. Then lastly, you need to find difference. Don't forget. So you take 775 minus 595. Answer 180. Question 7. So there is a sale where you have the first refrigerator at 10% discount and the second one at 20% discount. Okay, Mr. Raj paid 3893 for two identical refrigerators using the savings coupon as shown above. How much would how much more did he have to pay for the two refrigerators if he did not use the savings coupon? Okay, so to find how much he has to pay at first, we are looking at the original price. That is what he needs to pay at first. But they're asking for how much how much more would he have to pay? So original price versus the discounted price. So basically the discount, the amount that he gets to save. Okay, so original price is 100 units. If you want to find the original, then for the first fridge after discount would be 100 units minus 10 units. For the second one is 100 units minus 20 units. So in total, what is paid? It's the 90 and 80 units. So this total amount that he paid is 3893. Okay, so 170 units is 3893. So for 1 unit, this would be 22.9 for 1 unit. Okay, how much more did he have to pay? What he has to pay is 30 units. Okay, so 10 and 20. That's the extra. Sorry, 30. 30 times of 22.9 gives us $687. So this is the extra that he would have to pay. Question 8. Nina says some $2 notes and $5 notes in a ratio 5:3. When she took out 36 $2 notes and added some $5 notes, ratio became 2:3. Find the total value of all the $5 notes Mina saved at first. Okay, starting with ratio. This is talking about the number of notes. Okay, then she took out 36 $2 notes. So for $2 notes minus 36. Take note, this is all quantity, not value. Quantity means number of notes. Okay, then for the $5, added some, not sure how much. And lastly, ratio. to 3. Okay, so firstly, look at the change. This change here is 1 plus 1 minus, and it's the same number. We said added the same number. So the plus and minus would be the same. Sorry, same number. I shouldn't put question mark. I should write 36. Okay, if there's a reduction of 36 and then you add back 36, right? One thing doesn't change, which is the total. Okay, a total number of notes. So I add in total. Make it the same, becomes 40. All right, now figure out what is 36. 36 is the change in the $2 notes as well as the change in the $5 notes. So if you look at $2 notes, it went from 25 units to 16 units, and the change is 9 units. So that change is 36. Then 1 unit, total value of the $5 notes at first. $5 notes is 15 units. Okay, 15 units here. So this is the number of notes, but they want the total value. So now what you do is you take $65 notes and times 5. Okay, so answer $300. Question 9. Two rectangular tanks are shown below. At first, A was completely filled with water. 1/3 of tank B was filled with water. Water flowed out of tank A at a rate of 1.2 liters per minute. Water is flowing out at 1.2 liters per minute as well for tap B. Okay, so one is in, one is out. In tap A, water is flowing out. In tap B, water is flowing in. Let's label liter per minute. All right, firstly, tank A fully filled. Tank B is 1/3 filled. So if the height is 36, take 36 divided by 3 equals to 12. So this is actually 12 cm. Okay, then let's calculate. Since we have the rate of A, right? Let's find out how much the height changes every minute. A in 1 minute, 1200. 1200 is the rate. 1.2 liters converted to square cubic cm. Okay, so 1200 is the amount, the volume that is flowing out. The base area is 30 times 20, so I'll divide by 30 times 20 in order to find the change in height. Okay, so volume divided by length divided by breadth gives us height. So every minute, the water level goes down by 2 cm. Now for B, we do the same thing, but this time this is going down. Okay, so this time is going up. The amount that is added is also the same, 1200 every minute. Base area is 40 and 25. which is 1.2. So 1.2 cm, this is the increase in height every minute. Okay, now I'll show you a diagram. You have this uh, tank B. This is tank B 12 cm here. Okay, filled with water. Then the whole thing is 36. Sorry, I shouldn't use 36 because water is coming down. Like, I mean, water level is coming down from A and going up from B. So you want to ignore this 12. Okay, the distance or like the height that both are trying to cover when one goes down, one goes up, is this remaining portion, meaning 40 minus 12. Anything beyond 12 we will not want. Okay, we only look at the part where, when one goes down, the other one goes up. Where will they meet? Okay, so ignore this 12, 40 minus 12. 28, so 28 cm here. Now this one goes down by 2 cm each time. This one goes up by 1.2 cm each time. So they're eventually going to meet, right? Somewhere, maybe somewhere here, perhaps. So how long does it take? In 1 minute, you have one down 2 cm, one up 1.2 cm. So in 1 minute, A plus B, you don't, uh, it's not minus, but plus. So 2 plus 1.2 because you're closing up this gap. You're closing up this gap. So every 1 minute, the height difference decreases by 3.2. Okay, it closes the gap by 3.2. So the time taken will be this 28 cm divided by 3.2. Okay, so 8.75 minutes. Question 10, in the figure below, you have a rhombus ABCD, so which means you have equal sides. Okay, be careful, TDC is not isosceles. Okay, maybe I don't label this side because the side that is equal is actually AD, not TD. In case you thought that this is isosceles, but it's not. All right, then you have 134, 15, 106, RCP. Okay, this whole thing is 106. Find CTD, this angle here. Okay, so firstly, this is a straight line. Let's find this angle here. In order to find this, I will find this and this. Okay, so to find this, 180 minus 15 and 106. That is angle TCD. So from here, 59 degrees. Then here, this would be interior angles. 134 plus this will give us 180. Okay, interior angles add up to 180. So that's angle TDC. Maybe I just highlight the parallel lines. So interior angles are interior angles, this and this angle and this angle. 180 minus 134 is 46 degrees. So this is 46 degrees. Now we can find CTD using angles in a triangle. This is 75 degrees. Question 11. At a charity walkathon, there was an equal number of children who took part in either the 3 km walk or the 5 km walk. Okay, so equal number of children. There were 208 girls who took part in the 3 km walk and 162 girls who took part in the 5 km walk. So 60% of the boys took part in the 5 km walk. For every 1 km walked by the children, $10 was donated to charity. So part A, how many boys took part in the 5 km walk? Okay, so equal number, 3 km and 5 km equal number. So something is equal to something. Let's look at 3 km walk. 3 km walk, we have 208 girls. So this is number of girls. Plus how many boys? 208 girls who took part in the 3 km walk. 162 girls in the 5 km walk. 60% of the boys in the 5 km walk, which means that the 3 km walk, right, would be 40% of the boys. 5 km walk is the one in green, 162 girls plus 60% of the boys. All right, so over here, I'll take away, let's say I take away 40% of the boys from both sides. What's left is 208 on the left side, 162 on the right side, plus 20% boys. This means that 20% of the boys would be 208 minus 162. 46. So 46 is 20% of the boys. The question is asking how many boys took part in the 5 km walk. For the 5 km walk, it's 5 km walk. It's this one is your 3 km walk, right? And then this is your 5 km walk. So the number of boys we're actually trying to find is the 60% over here, 60%. Okay, so 60% B. 3 times 3, 46 times 3. Okay, so answer 138 for part A. Part B, find the total amount raised by the children in this charity walkathon. Okay, so for every 1 km walk, there's a $10 earned. So we need to find the total distance that they walk. There's a 10 km, sorry, there's a 3 km and a 5 km walk. So for the 3 km, how many of them? There's actually equal number, lah. So you just need to find one number, the number of children is the same. So you just find one side. So example, this one, 208 plus 40% B, or this one, 162 plus 60% B. Maybe we just use this since we have already found 60% B. So for the 5 km walk, it will be 162 plus 138, 800. So for the 3 km walk will also be 300 children. So just multiply to find the total distance. 300 times 5 and 300 times 3. Okay, so that's the total distance. 1500 plus 900, 2400. So every km $10 multiplied by $10. Okay, so the total amount collected would be $24,000. Question 12. Figure shows a path of width 2 meters in a rectangular garden of length 66 meters. The outline of the path is made up of quarter circles with center A, semicircles with center D and E, and straight lines AB equals to CD equals to EF. Okay, so A is missing. This is A. A, B, C, D, and EF are the inner radius of the quarter circles. Okay, so we are supposed to find the breadth of the rectangular garden. So from here, look at it, 66 meters. 66 meters, it seems like there are 5 equal parts, but it's not 5 equal parts. So be careful. The equal sides would be this one. Equal parts would be this, A to C, A to C. So it's the wider radius of the bigger diameter. Sorry, the bigger quadrant. Okay, then here you have another one. And then here E from this point to this point. Now this part here is actually the diameter of the smaller semicircle. Okay, not the bigger one. So since the smaller semicircle has a radius that is 2 meters shorter, so we would have uh, almost 2 times of this AC. Okay, almost 2 times. So how to make it 2 times? You have to add extra 2 meters to CD and add another 2 meters to this part here. So we take 66 plus 2 plus 2, which is 70. Then now we would have 5 times of the radius of the bigger quadrant. Okay, so radius of the bigger quadrant, 70 divided by 5, which is 14. So this part here is 14. Which also means that this part here is also 14, and this part here is also 14. So the breadth would be 14 times 2. 28 cm. So this question can be a bit tricky because of the extra 2 meters. So look carefully to see whether you're looking at the smaller or the biggest or the bigger radius. Okay, for B, find the area of the path. Now the path can be split into a few parts. So this part here, we have 3, 4, 5, 5 of it, and then a rectangle here. Okay, so to find each part of this each of this part here, we take bigger quadrant minus area of smaller quadrant. Okay, so the bigger quadrant, 1/4 times pi, which is 3.14, times the radius of the bigger quadrant, which was 14 meters, the one that we found earlier. This would give us 153.86. The smaller radius is 2 meters less. So this is times 12 times 12. 113.04. So each part would be bigger quadrant minus smaller quadrant. 40.82. Since there are 5 of those, 1, 2, 3, 4, 5, take this multiply by 5. Then lastly, we have the rectangle over here. This would be 2 times 14. Because this length is 14, breadth is 2. So 2 times 14, 28. Now we add them up, 28 plus 204.1. 232.1 square meters. Okay, let's look at question 13. 13 is a graph question. Okay, so it shows the rate of two machines, A and B, assembling toy cars over a period of 12 hours. Together, A and B. So we have the time in hours, and then we have the number of toy cars that both machines make together. Okay, next, part A. In the first 6 hours, both machines assembled an equal number of toy cars each. How many toy cars can each machine pack in 1 hour during this period of time? So if you look at the graph, in the first 6 hours, read carefully, this is not 400, but this is 420. So in 6 hours, both A and B makes 420 toys. Then each in 6 hours, because they said equal number, to divide by 2, which is 210. And lastly, you're supposed to find in 1 hour. So divide by 6, which is 35. 35 toy cars. Okay, B, during the last 6 hours, the rate at which A was assembling toy carts or toy cars was increased while B continued assembling toy cars at the same rate. How many more toy cars did A assemble per hour than B during this period of time? Okay, so if you look at the next 6 hours, the rate changes, right? Because A started making at a faster rate. So in this 6 hours, we're looking at 1380 versus 420. Okay, so find this increase. That is the 6 hours by both A and B. 1380 minus 420, 960. And the rate for B is the same. So 6 hours for B is 210 as what we have in part A, minus off to get 6 hours for A. which is 750. Then we want to find per hour, so 1 hour for A. 750 divided by 6, 125. Okay, so 125 compared to B per hour. B per hour is 35. So 125 minus 35. Answer 90 more toy cars per hour. Question 14. Sherry baked cookies and packed them to sell. Graphs below shows the number of cookies she baked and the number of packets sold from. This is the number of packets sold from week 1 to week 4. So each packet was filled with the same number of cookies. So over here, the first one, as the number of packets increase, the number of cookies baked would increase as well. Okay, because you have more packets baked. You have more cookies baked. They are put into packets equally. The number of packets will increase at a consistent rate. Then the second one shows you how much was being sold. Okay, so how many cookies were packed in one? They should packed in one packet. Let's look at the first one. If there are 40 packets, or if there are 20 packets, number of cookies would be 300. So you want to find how many are there in each packet. Take 300, divide by 20. Which is 15. So every packet has 15 cookies. Okay, so one packet. How many more packets of cookies did she sell in week 3 than in week 1? Week 3. Okay, let's label this as interval of 4. So it's 20, 16, 36, and 40. How many more in week 3 than week 1? So 36 minus 20. So answer 16. Part C. Number of packets of cookies Sherry sold in week 5 increased by 30% compared to week 4. How many cookies did she sell in week 5? Okay, week 5 is not shown here, but it is 30% more than this. So week 4 is the original we're comparing against. Week 4 is 100%. So week 4, 100%. Week 5 is 130%. So 100% is 40. You can do 1% or 10%. 40 divided by 10. Then you want to find week 5, 130%. So 4 times 13, 52. Now, take note, 52 is the number of packets. Okay, over here, this is number of packets. But the question is asking how many cookies. So earlier on, we know that every packet has 15 cookies. So if we have 52 packets, number of cookies, 52 times 15. 780. Okay, question 15. In this figure, AC is triangle, AF equals to AB, EF equals to ED. So you have isosceles triangles. It's sum of ABF here, and EDF is 1, 2, 5. Okay, so this here, okay, same as EDF not same, but they add up to 125. Okay, they are not equal, but they add up to 125. So you're supposed to find BFD over here. Now, which two angles are the same? Uh, um, this one, same, right? And then this one, and this one. So can you see that if these two add up to 125, means these two add up to 125. So this and this adds up to 125. So to find BFD, you just need to take 180 minus 125. So answer 55 degrees. Sum of BAF and AEC. Okay, so we're looking at the sum of this and this. If you see there are two isosceles triangles, total angle would be 180 times 2. Then these two is 125. These two are 125. So you're left with the two green ones. So you just take 180 times 2 first. Hundred eighty times 2. Then minus the light blue, which is 125 in total. Dark blue, 125 in total. So answer 110. Okay, the two green ones will be 110 degrees. Question 16. Fill up the table for figure 6. What's the pattern here? Plus 2, plus 2, plus 2. So don't be mistaken. The next one is pattern. This is pattern 6 we're looking for, not pattern 5. So from 4 to 5, 5 to 6. Add 4, so 10 plus 4, 14. Here plus 3. And then here plus 3 plus 3 means plus 6. So this is 20. Alternatively, you can just take 6 plus 14. Find the total number of squares and triangles in figure 102. Now, if you look at total number of squares and triangles, pattern is a common difference of 3. So if figure 102, how many intervals are there? So you have minus 1, which is 101. 101 intervals would be 101 times 3, which is 303. Then lastly, you need to add the first pattern, which is 5. So 303 plus 5. Here's the interval concept for pattern questions with common difference. Question 3, find a figure number which has a total of 1742 squares and triangles. So this time we're doing the opposite. So firstly, we want to take away this first pattern, which is 5. 1742 minus 5. Now 1737 is made up of all intervals, which is all the plus 3's. So to find number of intervals, we take 1737 divide by 3, which is 579 from number of intervals to pattern number, figure number, to add 1. So answer 580. Last question. 17 units packed 2 types of books into 4 shelves. A big book had a thickness of 9 cm, small book thickness of 5 cm, as shown in figure 1. So there are 4 shelves here, W, X, Y, Z, stacked on top of one another as shown. Okay, then books were placed next to each other without any gaps. So look at W here was packed with greatest number of big books, leaving a 3 cm gap, whereas X packed with the greatest number of small books. So this is as shown. Now, number of small books in X was 11 more than the number of big books in W. Okay, so for this question, you can use what we use for average. So basically, you have 9 cm, 9 cm, 9 cm, right? So I don't know how many is that, but I'll do this. So 9 cm all the way. Okay, so there is an extra of 3 cm gap. Okay, so 9 cm each, and then there's this extra 3 cm gap, which is here. Then for shelf X, so that whole thing, this whole thing has a total that is equal to some small books here. Okay, equal number, but the small books would have 11 more. So here times 11, the extra goes to the right. You compare 5 times 11, which is 55. So we're comparing 3 versus 55. There is an increase of 52. So 55 minus 3. That's how I get 52. So if there's a difference of 52 on the right side, means that there's a difference of 52 on the left side, which is the top more than the bottom. So the top one is 9. Every big versus every small. The difference would be 9 minus 5. Now we already found that the difference is 52. So if we take 52 divide by 4, we get 13. So there's actually 13 here. What's the length of book of shelf X? Now, whether you find shelf X or shelf W, the answer should be the same. Okay, because length of the shelf, they're all the same for this question. So from here, 13, here 13, length of shelf X would be 13 times 9 plus 3. Which is 120 cm. Okay, next part, Eunice packed a total of 36 big and some small books in Y and Z. Okay, these are the other 2 shelves. So the books are packed here, as shown. So how many big books were packed in shelf Y and Z combined? Okay, this is actually assumption question. So firstly, let's find the total length that we are trying to fill up exactly. Each shelf is 120. So since there's 2, we are trying to fit a total length of 240 cm. Okay, so since they're asking for big, let's assume or suppose all are small. So 36 big and small. So first step, 36 are all small, so 36 times 5, which is 180. Now the total length is supposed to be 240. So 240 minus 180. We don't have enough, right? So we minus, which is 60 cm. If we need extra 60 cm, we should be converting the small to big. Okay, and that's what we call one exchange. So small to big, 9 minus 5, which is 4. Then the number of exchanges. So if there's an extra 60 that we need to increase by, every exchange gives us extra 4. Then the number of times I need to do that would be 15. Okay, so 60 divided by 4 is 15. Since I'm doing that 15 times, I'm changing small to big. So this is the number of big books. Okay, so 15 books. 15 big books. Okay, so with that as the end of this paper, Rosyth P6 Prelim 2024, paper 2.